The truth is, we all want tasty, shelf-stable, and convenient foods while being healthy and never have to cook again. Don't we, Corey?
Isn't that basically, you mean processed foods?
Yeah, well, the big question, however, still remains is that which processed food is good and which one is bad?
Well, I think the first step to unlocking this Pandora's box is to understand the fact that our own body right here is a food processor. What if we look at it that way?
That's actually a great idea. Welcome to the Ketogeek podcast. Let's do this.
Health, nutrition, fitness, low-carb lifestyle.
Hello, everybody. Welcome back to the Ketogeek podcast. My name is Fahad, and I am, as always, joined by the one and only
Corey,
the alchemist. Corey, we just came back from a hike. How are you today?
Doing good, man. Like, it was a really good hike. Got some good sleep last night. Had a good breakfast and spent some time outdoors. Can't ask for anything better.
Life is great. I know we're starting to get into we're having this sinusoidal wave of ups and downs here across the world, actually. And that's not part of our world. But, you know, I think we'll get through this. We'll make it.
Oh, we will.
So, Corey, this is a great podcast. And this is something we've been hyping for literally 2.5 years now. And we're finally going to get into what we call food structure and food architecture. Guys, you should be all excited listening to this podcast. Share this thing around. This is something that is a lot of fun. I had a blast doing research with this, and you saw some of the notes. What do you think, man?
We went through the notes, and I have to say, this is honestly the holy grail, man. Like, it's unbelievable. I've always, on our journey in Ketogeek, we've been teasing out this direction for a very long time, and when you think about it, it really is the only thing that makes perfect sense.
Yes, and once you're done with this show, you're going to start noticing how everything starts lighting up and all these explanations start popping in. It's the constellation forming together finally. So guys and gals, this is a podcast you guys should be watching. Share this with your friends. Move it all around. This is going to be a lot of fun. However, before we get into the podcast, we need to drop on who we are. We are actually Ketogeek. We are a food business. And Corey, what do we do?
Well, we're a food business, and we like to use the best science to create literally the best food products. And I have to say that this podcast is really going to open up your eyes as to why energy pods even exist now. And if we're going to talk about food products, we have to plug some energy pods here. And why does it make it the best snack, Fahad?
Energy pods are something that started off with a vision to make healthy food products that are geared towards everybody's lifestyle, whether you're a productive individual, a mother who's taking their kids to school and they just need that extra snack. We know one. One of them actually lives like 3 doors away from us. She's probably listening to our podcast as we speak as well. So, but yeah, a lot of people use it. A lot of our friends use this energy pod. What they do is they put their life on productive autopilot and consume these energy pods. They are sugar-free snacks, or you can combine them with other things and turn them into a side meal or an add-on. Like the other day on Instagram, I posted this protein shake. I took the energy pod. I then added about 8 to 10 ounces of water to it, and then 30 grams of whopping protein. And the total macronutrient composition was insane. I drank that concoction combined with, I added sucralose as a sweetener. So it became this amazing energy drink that I drank after my workout. It was amazing. And then I went to do the rest of the work day. So, and I know you've been consuming these energy pods too. How have you been?
Absolutely. Yeah. I thought if you guys are following the IG stories, another one was posted recently that Fahad brought over to me, and it was chocolate energy pod desserts. We had chocolate chips in there.
Oh,
we had whipped cream on top, and it was beautiful. We actually consumed it alongside ice cream, and we were both laughing because our lifestyle is just kind of devoid of green things and fruits. And here we are eating meat all day and protein shakes and whatnot. And then we get to the evening and we're eating high energy ice cream, high energy pod. It was absolutely delicious.
We called it the happy diet.
Happy diet.
Yeah, so that's what we think. You know, we've always envisioned our product as something that adds to people's lives. And it's a really good product. It's sugar-free. It has erythritol and monk fruit. Erythritol is a totally inert sweetener. It really does nothing. And monk fruit has some protective capabilities as well. They've actually done studies on erythritol, on how inert it is. It doesn't raise your sugar levels. It doesn't have any impact on insulin. It's really awesome. And it is the polyol, or the sugar alcohol, with the highest amount of tolerance, even higher than allulose or rare sugar. So it's really, really good. It has a slight cooling effect. And overall, it adds to the whole energy pod flair. We make our own ghee as well, as some of you people know. It is made from local butter over here, and we just make it ourselves and put it into the energy pot along with MCT oil, some amazing cocoa, the best cocoa we can find in the entire planet, or whatever we have access to be honest, and then add some almonds to it. So all of this concoction is then just blended and combined together to create this beautiful, tasty snack that you can take on the go. It's totally shelf stable. So what are you waiting for? Go buy it. And actually, tell us how you use it. We'd be interested. Yeah. Leave us a review. That would be amazing too. And so these energy pods, you can find them on Amazon. You can go to the Ketogeek website. And while you're leaving reviews, why not just leave a review for this podcast? Let's pause for like 3 seconds, more like 1 second. All right. I think everybody's probably left reviews by now on everywhere. So, guys and gals, energy pods are amazing, and you guys are amazing for joining us on this podcast as well. I think for now we're still in stock at the moment, and we'll try to remain in stock as much as possible, but we do get sold out. And what's really cool, Corey, is that Ketogeek is a bit more than just about the food. Our container is 100% recyclable. We care about those little tiny details. I think caring for the environment is important, especially in times like these. The paperboard spoon, it supports regenerative forestry, which is really cool. We know the business that makes those paperboard spoons. They're literally like 45 minutes away here in California that make them. They're really cool people. They're really an amazing company. So we do all of this homework because let's think about it. It's all about creating a better future. It's about innovating. And we've been watching The Expanse recently, and that's a beautiful world.
It really is. Just 2 episodes deep, and I am absolutely, I'm shocked. Like, it's a crazy show, but it's amazing. Absolutely. And I want to strive towards an amazing world with Ketogeek.
Yes, we need to become an interplanetary, intergalactic civilization, I think. We're so stuck these days in these little trivial battles and these selfish ideologies when we could be focusing on creating a better world, exploring, learning, and this starts with discerning. Discerning is very important. In our time of information overload, discernment is the strongest tool people can have. And you have to sharpen that with good knowledge that we try to provide with our Ketogeek podcast and then apply it to our products. So when you buy our product or listen to our podcast or leave us reviews, you're not just buying a food product. You're pushing for something great. We got the intentions. We're pushing hard, but we can't do it without you. We need your support. Give us what you can give us, and we will take it, and we will make the best out of it. Let's make this world better. And so, is there anything else I've missed out on?
No, I think we're covering all the bases here at Ketogeek, and as you follow the journey of Ketogeek, you'll just see that we continually evolve day by day, and we hope you can join us on this amazing adventure.
Indeed, Corey. Wise words. Now let's get back to our episode, and this one is fascinating, as we've mentioned. We're going to start focusing on our body's digestive system as a food processor. Interesting, right?
Yeah, it sure is.
And then in the second part, we're going to talk about how various food structures consisting of carbohydrates, fats, and proteins are digested in the body and their bioavailability, and interestingly, how the body responds to each of them. Now, we've talked about the endocrine, metabolic, and neural response. Now, how is all of this modulated? You have to go upstream. You've already went downstream into the body. Now, let's go a bit upstream and see what are the controllers there. And that starts off with the food architecture. So, guys and gals, this is an amazing show. I would like to give some credit to the following authors, whose names are Mike Boland, Matt Golding, and Harjinder Singh. They are of the Reddit Institute of Technology and they've done some amazing work on food structure and architecture. I will leave a link to their paper trails and potentially their book as well. You guys can read it out. I would say 99.99% of the credit goes to them. If they and I just everything that I've learned, a lot of it just comes from them, and we will discuss a lot of their work. So go check them out, give them your support. And I wish I could have done the podcast with them. I've actually sent them invites as well, but these are busy people, man. So with all of that said and done, Corey, you ready for this?
Oh yeah, let's do this.
Behold, everybody, to the podcast, to food structure. Corey, I think, first of all, we need to lay down the framework before we delve into the subtle dynamics. As always, we like to start off with certain definitions and how we think about them. A lot of this is paraphrased from different sources, and a lot of it is our additions. And we're going to begin by first asking the most basic question. Now, Corey, you don't have to look at the notes, but my question to you would be, what is food? Or you can take the notes. Either way is fine.
No, what is food? It's the thing that gives us energy, obviously. And it also, on a metaphysical level, it binds humans together, brings societies together, and has always done so because it brings us pleasure and joy. It gives us energy to move throughout the next day. And what better thing is there to do to celebrate life, to sit down with your family, your friends, and eat a delicious, tasty, nutritious meal? And as you digest it and sit there and maybe have a sip of wine while you're here in Napa Valley, you just think of all these wonderful memories that come along with the food, and you solidify these things. And food is just so important. And we get to dive into what food actually is on a structural level, a little bit more of an analytical view of it, but we want to understand and agree with the rest of humanity that food is so important.
Exactly. And what use is science and all this knowledge if we cannot create beautiful memories and experiences? Vast cultures have been built around the concept of eating. A lot of these festivals around the world, the harvesting that goes on, it's a beautiful experience. We cannot trivialize this fact, no matter how much scientific we get. But if we do have to go a little bit scientific, let's put a simple definition to it. I would say food is a complex web of various forms of nutrients and non-nutritive components woven together to provide us with sustenance and while giving us pleasure and joy. Now, I think over here, it's also very important to understand the digestive system. We mentioned where we're going to talk about it, so let's start with it. And in order to understand food digestion, we need to actually define what food digestion actually is. So the digestion is the process of breaking down food structure to release nutrients that can be absorbed by the GI tract. The GI tract, which we've beaten down to the dead horse pulp to the end of the world in the last few podcasts, it starts from the mouth or the oral cavity, continues to the esophagus, which is a tube going down straight into the stomach, followed by going into the small intestines, which is also a tube network, and finally into the large intestine or the colon, and so forth. And then you just excrete the food out. That's basically the GI tract in a very simple way. The GI tract is also lined with mucus and submucosal layer, and it all has glands lining up the inner tract that supply water, digestive enzymes, and other chemicals that are necessary for digesting the food we eat. So digestion is done both physically and chemically. Mixing takes place when muscles contract rhythmically throughout the tract. And then the second way it is physically digested is propelling. Propelling takes place by a process called peristalsis, which is a wave-like motion of constriction and relaxation of the intestinal muscles that push food forward. So, Corey, we're going to divide the whole thing into 4 sections when it comes to digestion. We're going to talk about the mouth, what happens in the mouth. Then we're going to talk about the stomach. Then we're going to talk about the small intestines and the large intestines. So let's start off with the mouth. When you look at the mouth, Corey, what do you think?
How freaky. There's little stones in there with points, and some are sharper than others, and some look like they can grind things down. And then you have this strange muscle, the tongue. It's so strong. I've heard the strongest muscle in our body is actually the tongue, per weight at least. And that kind of makes sense as we dive into this podcast and we started talking about bolus and how it is a very big role in one of those digestion actions that we talked about earlier, mixing. So this is going to be really interesting. Yeah, the mouth is in general kind of freaky when you think about it, but people do have nice smiles.
Yeah, and some people use mouth to kiss each other. So there's that part about it. The mouth is very important. So when it comes to digestion, the mouth is the first place where digestion takes place. It consists of various parts such as your teeth, tongue, lips, palate, throat, esophagus, which work to start the process of digestion. Interestingly, the starting pH of this environment is neutral, while the temperature remains at about 37 Celsius, which is the body temperature, and both of these get modified by the food you consume. Food enters through the mouth and is processed both mechanically and chemically as it passes through the throat and into the esophagus. Mechanically, by chewing, primarily done by our teeth, the food matrix is broken down into small particles. Then, mixing by the help of the tongue with the saliva allows the formulation of the bolus in our mouth. Mixing also heats or cools the food to reach body temperature. So that's why when you're eating something hot or something cold, it immediately doesn't go down the esophagus. It is processed by our tongue and the saliva combining together to cool it down or heat it up in the case of an ice cream. The time the food spends inside the mouth depends on the type of food, but this can be anywhere from 10 seconds to 100 seconds. Solids and semi-solid foods are broken down until they reach a size small enough for swallowing. Fluids, on the other hand, are swallowed rapidly with short period of exposure to saliva. The process of chewing also releases the flavor in our mouth, which is pretty awesome as well. You just crack stuff and flavor goes in. Pertaining to particle size, what's also very fascinating due to chewing, is interesting to note over here that there was a study done among 10 individuals that chewed on nuts and vegetables, specifically peanuts, almonds, pistachios, cauliflower, radish, and carrots. It was noted that the particle size distribution was the same among these individuals.
Interesting.
So we're starting to see some commonalities here.
Standardization.
Yeah, and science thrives on finding commonalities and patterns. It's what we do as human beings. Additionally, it was found that the bolus weight, this was noted in another study, is about 4 to 18 grams, which is about 5 to 25 milliliters in volume. Pretty cool. Saliva, whose pH is about 6.8, so it's kind of pretty neutral, and it is also 99% water, contains enzymes, carbonic anhydrase, and various proteins. These enzymes include alpha amylase, which is an enzyme that catalyzes the hydrolysis, which is basically the splitting of a compound by adding water, of starches into smaller carbohydrate molecules. Meanwhile, the carbonic anhydrase is suggested to help maintain appropriate pH on the tooth and oral surfaces. The proteins in the mouth include immunoglobulins, which are proteins that function as antibodies, certain antibacterial proteins, proline-rich proteins which inactivate tannins, wine, and preserve dietary proteins, lysozyme, an antimicrobial protein that cleaves bacterial cell walls, and lactoferrin, which defends against microbial growth, inflammation, and iron overload. So the mouth's got some pretty interesting defenses going on, Corey.
It's well equipped.
Yeah, it's got evolution behind it. Saliva, combined with the movements in the mouth, tries to bring the food closer to body temperature at about 37 Celsius. When starchy foods are consumed, salivary amylase partially digests or hydrolyzes the amylase, which is a straight-chain polymer, and also acts on amylopectin, which is a branched chain starch polymer. So these are the two different kinds that make up starch. This hydrolysis causes a decrease in the viscosity of the food. So that melt in your mouth sensation that you get is because of this salivary amylase just boom attacking. And it's very important to note, Corey, this is a study that I found out of after a little bit of digging. Now, this doesn't have to pertain specifically to this. Well, it actually does pertain a lot to what we're talking about. It was done in malnourished kids, but I think you can abstract some gold nuggets here. So the study was conducted in 2018. It was a randomized, double-blind, controlled crossover trial, which is powerful, in 120 12 to 35-month-old Burkinabe children, where amylase was added to the porridge, and just by adding that amylase, the energy intake went up by 47 to 67%, which is huge. When we talk about 50%, what we mean is if you're eating 1,000 calories, it's going up to 1,500 calories. If you're eating 2,000 calories, you're going to 3,000 calories. That's how much of a difference it is by just adding amylase.
Major.
So now you're starting to see that disrupting the architecture a little bit and sort of pre-digesting, which is what amylase does, it ramps up the energy intake substantially. So when everybody talks about processed foods, now we're starting to get the picture.
Right. So, gotta cook your foods, boys and girls.
So processed foods is a double-edged sword here. Some people have got that part right, but there's other parts they didn't get right, and we're going to talk a little bit more about it. So the mouth itself contains a layer of this jelly-like mucin, which is made of various proteins and fats that protect the mouth against chemical, mechanical, and microbial damage to underlying tissues, while also preventing dryness. So there's a reason why your mouth doesn't dry up in 10 minutes when you're, sleeping, for example. This same mucin, it wears multiple hats. It also binds to oil droplet surfaces in food emulsions to separate away fat droplets in the form of little sediments. So in other words, this mucin just breaks that emulsion. It's really fascinating. However, when only fat or oil, not an emulsion, is consumed, the mucins simply adsorb on the surface of the fat molecule and create an oil-water emulsion. So it creates an emulsion. Fascinating. The difference between absorb and adsorb is substantial, guys and gals. Absorb is when two materials chemically combine and or one material reaches into another. Adsorb, on the other hand, is when one material sticks to the surface of another material. So it doesn't go outside, it just stays outside.
And that's like a delicious Christmas present.
It is. What Christmas present are you going to give to someone you care about?
I almost always give a very nice stick of salumi to my grandfather for Christmas. So maybe that is actually very relatable to this podcast today.
What's a salumi?
Salami. Italian salumi. It's very Napa Valley, posh pronunciation.
I should compliment that by giving everybody butter, just because French.
Let's do it.
All right. All right, let's go back. I love these tangents, but there are certain people who are like, get back, please. Come on, man. Though there seems to be lipase in the mouth, which is an enzyme that is supposed to hypothetically break or catalyze the digestion of fat, the actual impact of this lipase is controversial or thought to be weak in humans. And when all of this is said and done in the mouth, the food moves down the esophagus into the land of the unknown. No, it's not the land of the unknown, but it goes into the stomach for gastric processing. We should start a band, like a metal band called Gastric Processing.
Gastric Processing. And definitely write it out into a way you can't really read it.
It should be like Metallica, but called Gastric Processing.
Gastric Talica.
Oh, man. But I think it would be a metal band. Gastric Processing can't be... Maybe it could be a punk or a metal band.
We're going to have, as our vocalist, Stomach Growls.
There's a band on YouTube. It's called Hatebeak. And the lead singer is a parrot.
Yes. YouTube that right now, every boys and girls. Do it. It's funny.
I think it's a screamo metal band, and that lead singer is straight up just a parrot. It's freaking amazing. Anyway, stomach. Let's go into the stomach. Well, we're not going into the stomach, but the food is going into the stomach. The stomach is a J-shaped organ. If you look up stomach, everybody describes the stomach as a J-shaped organ. The stomach is a J-shaped organ right underneath the esophagus that further mechanically and chemically processes the food before it is passed into the small intestines. The stomach consists of the fundus and the cardia at the very top, followed by the body, then the antrum and the pylorus at the end. There's also a very small valve at the end called the pyloric sphincter. Is that a good way to pronounce it? I think that's right.
It is.
So the pyloric sphincter, which opens and closes, which controls the flow of the food from the stomach into the small intestines. I think every time we make, I make or you make a mistake in the pronunciation, people should take a shot.
Yeah, absolutely.
They'll be drunk in like 3 seconds. All right. No, shot of energy, but no, that's just torture. Just eat one energy pot a day.
Yikes.
One is fine.
You'll have so much energy, you'll be able to leave the planet.
You're gonna turn to Captain Planet.
I love that show.
It was good. It's powered by the sun. Oh man, old references. All right. When at rest with no food intake, the gastric juice in the stomach has a pH between 1 and 3. That's pretty darn low. However, once the food is in the stomach, the pH rises to 5.5 to 7, while decreasing to 4 to 5 pH an hour later, which coincides with half of the stomach emptying. Meanwhile, the stomach slowly and methodically grinds the food into particles in the size of 1 to 2 millimeters. Now we're getting more standardized. While at the same time mixing everything together to create this mixture called chyme. I would like to chime in. Not that chime. It's CHYME, chime. Once the stomach is completely empty at about 150 minutes, the pH returns to about 1 to 3. The purpose of the acid in the stomach is to ensure that there is no microbial growth inside the stomach as the food is being processed for about 2 hours or so. The acid also helps break down the food and interacts in significant ways with the food itself. For instance, at very low pH, proteins can form cluster networks, while fats may separate away to form bigger droplets. The gastric juice is chemically composed of pepsin and lipase, as well as which are basically enzymes that break down proteins into peptides, the pepsin, and then lipase is basically an enzyme that breaks down fats into fatty acids and glycerols. The clusters and droplets of fats and proteins formed by this acidic environment can have a different way of engaging with the digestive enzymes. So all of this is just kind of interwoven. However, generally, and because of factors like these that we talked about, some or many proteins are digested by the pepsin, while some may resist the digestive process. Physiological surfactants, such as phospholipids, which physiological means like within the body, such phospholipids from the gastric mucosa are known to affect the digestion of proteins. For example, using a vitro model, it was shown that the presence of physiological phospholipids did not affect the resistance of beta-lactoglobulin, which is a major whey protein of cow milk, to pepsinolysis, but protected the protein from subsequent pancreatic proteolysis. In other words, just to put things simply, because of the presence of physiological phospholipids and how they interacted with this specific milk protein, the protein digestion would be resisted in the small intestines, but this would most likely reflect a slightly delayed amino acid presence in the bloodstream. So you're starting to see how things are starting to make sense. Like all these tiny little factors that you didn't think about play a key role downstream. Henceforth, interestingly, the proteolysis of beta-lactoglobulin, which again is the major whey protein, Bipepsin is more efficient when it is adsorbed at the surface of the oil droplets rather than when it is in a solution. This has been attributed to a possible change in the conformation of the beta-lactoglobulin molecules upon adsorption at the oil-water interface, which exposes the peptide cleavage sites for proteolysis, or digestion by the protein enzyme. Also, interestingly, adsorbed alpha-lactalbumin in oil and water emulsions seems to be more resistant to hydrolysis by pepsin, which is the digestive enzymes or proteins, compared with native alpha-lactalbumin in solution. In other words, to put things very simply again, a solution of this specific milk protein, when combined thoroughly with oil and water, was more resistant to digestion when compared with milk protein alone. So now basic architectures of food are forming here in combination with fat, protein, and water. Not just protein or fat, it's a combination that's starting to happen over here. These are all playing together to create structures, and each structure has a unique footprint in the digestive system. Proteolytic products, that is, products containing proteins, modulate the secretion of acid, modulate secretion of pepsinogen, which is further converted to pepsin by the gastric acid, and also modulate gastric emptying. About 10 to 30% of lipids are hydrolyzed into free fatty acids and diacylglycerols by the stomach lipase. The gastric emptying rate, or the rate at which food leaves the stomach, depends on the viscosity and the structure for the food material remaining under these prevailing conditions that we all just talked about, like this acidic condition and so forth. In some food systems, phase separation can occur between a water and fat phase, sort of like a creaming effect, in which the lipid or fat rises to the top because of its low density. The water phase is usually emptied faster than the oil phase inside the stomach, which is also pretty cool. I saw this one study as well in which they showed that at nighttime, after eating like a high-fat sort of meal, I barely remember it, but I still remember it. And so if you sleep at I think whether it was a right or left side, fat emptied first compared to water in those situations. It was really
very interesting.
Yeah, because of the creaming effect. Mm-hmm. All right, so once the stomach is done processing, food moves into the small intestines. Corey, do you have anything to say over here?
What I got to say right now is that we're starting to really understand the food structure and why when we go back to our talk about pepsin and how it interacted with those different proteins and emulsions and water and oil, and how wildly different that becomes in our body just by a simple mechanical mixing, perhaps. If you just blended this stuff together in a blender and you wanted to change exactly how this substance interacted inside your body, you can immediately do that. It's really easy.
Bingo. So all of these interesting factors are in play, and we're starting to tease them out one by one. And this is going to be a long journey when it comes to understanding these things. Now, when we move into the small intestines, let's dig deep into it. Well, just literally and figuratively, I guess. Inside the small intestines, majority of the digestion of the food and release and absorption of nutrients takes place. The intestines consist of three parts: the duodenum, the jejunum, and the ileum. I wonder who names all of these difficult terms.
That's like numbs quite a bit.
Yeah. They're tough, man.
Yeah. Biology
has always been tough. Can we have some computer scientists just run through this thing again and just change it?
Let's build an AI program to rename everything. How about that?
The stomach function.
Done. Perfect.
A pointer instead of a food.
Yeah, make sure you call the function correctly, otherwise you won't use lipase to digest what you need to digest, and you're screwed in your program.
Yeah. And then array of nutrients instead of just nutrients. All the computer science majors are like, yes, thank you.
Food objects.
Food objects. Oh man, this is such nerdiness. We're such huge nerds. We tap into every sort of knowledge base. We're insane people. Oh man, last year we were learning about cloud computing. It was crazy stuff.
Oh my gosh. Every year's a new journey.
React Native, AWS, holy crap.
I got through most of JavaScript and then, had to start working a 40-hour-a-week job. But yeah, that stuff was crazy, man. Very fun.
Yeah, app development, all that stuff. Cool stuff. Anyway, let's go back to the stomach. Let's go back to biology. The duodenum is the first part, which is about 0.3 meters long, which is about roughly 1 foot. And it is the first part where the digested food moves from the gastric acid to a neutral pH environment while being exposed to digestive secretions from the pancreas. Corey, I just want to hit a little pause here. Have you heard of something called the alkaline diet?
Yeah. On paper, it sounds pretty cool. Like, supposedly we, think of acid and we always think of right away, what is the acid that it can melt pretty much just about anything? I'm forgetting the exact acid, but it was used in Breaking Bad to melt down a body completely. And that was a very interesting scene. I don't want to ruin it for anybody. It was a very beautiful scene. And then we think of alkaline, and alkaline is the opposite of acid. And obviously you go, oh yeah, I want alkaline stuff in me, not things that are going to melt my intestines away.
Yep. And it's like intuitive, sort of.
Right.
But what's interesting to note over here is that after this sort of extreme acid bath and alkaline bath, it's kind of hard to sort of make sense. It doesn't make sense over here.
No.
It all goes through the same process, and there are limitations. There are certain temperatures and pH at which the body likes to, it's like a homeostatic state.
Right.
And I also remember sending you a message very recently where we looked at a list of different plant-based foods and animal-based foods, and we found out very interestingly that plant-based foods are way more acidic.
Yeah, I sent at least 3 different laughing emojis to that text because I read it, looked at it immediately, and understood exactly what you meant there. And on the very bottom, you're looking at meat. It's freaking alkaline. And the propaganda pushes that meat is highly acidic and dangerous for your body and yada yada, but that's the extreme side of things, of course. You have to go to the far reaches of Instagram and social media networks to find these people, but that's what they're pushing, and I just had to make a big laugh about that because remember we went carnivore after our fateful podcast with Sean Baker, and we didn't melt away.
Yeah. Oh man, the alkaline diet is just kind of BS.
Indeed.
Hate to break it.
It's too bad.
Yeah, it just doesn't make sense from a scientific perspective. It stands on intuitive grounds, but when it comes to science, it's. I mean, lemons are very acidic.
Indeed, they really are.
But they're plants.
Yes.
So, lobster. I guess the best animal food on an alkaline diet would be lobsters. Lobsters are pretty alkaline. They're like the most alkaline foods out there.
Then go get all the lobsters, boys and girls, all of them.
All right, we've sidetracked enough, man. Let's go back to our small intestines. After covering the duodenum, 10 years ago, we're going to talk about the jejunum. Jejunum, actually. The jejunum is about 2.5 meters long, and the ileum is about 3 meters long. Both the jejunum and ileum are large incubating regions that allow enzymes to digest the food and absorb nutrients.
And how did the food, let's go back to one of our definitions earlier. I'm pretty sure this is where the food is propelled through these tubes, the contraction and relaxing of the small intestines to move them along. Is that correct?
Yes, that is absolutely correct over here as well. So this whole mechanical and chemical process just keeps continuing down the road. And what's also interesting is that the surface area of the small intestines is huge, especially the jejunum and ileum, as we've noted over here. Because both the jejunum and ileum have this wrinkly and folding surface, the absorptive surface area is about 30 to 35 meters square, which is about 320 to 375 square foot. Not the best comparison here, Corey, but the average size of an apartment in the United States is 941 square foot.
And I have a good idea of what 320, 375 looks like because I used to live in a space that was roughly 400 square feet. So, yeah, my intestines spread all over the dang place in that place.
Oh, it's cool. Our entire body is just a whole new ecosystem of itself. But here, while I was doing some research, there were some articles that posted that the surface area was 260 to 300 meters square.
Wow.
But there was a study done again in 2014 called Surface Area of the Digestive Tract Revisited, and they changed the amount to about 30 to 35 meters square. So that's the correct amount.
That seems a little bit more reasonable.
Yeah, but 260 to 300 just sounds cool.
It does, yeah. It sounds like we have an infinite universe inside of us.
Yeah, why do we fall for just bigger numbers? I guess they're just more catchy.
They're more fun, you know.
Yeah.
You know, in America, we like to talk about, we like to compare things to the size of a football field. How many football fields is that?
Oh, yeah. We
I actually don't know the answers to that right now.
I think we Americans, pardon my language, love to have dick measuring competitions.
Ah.
So, oh man. I love this country, though. It's a beautiful place.
Indeed.
I love the world, and we need to make it better. So, back to the small intestines. The intestines, they have something called the pancreatic juice that is thrown in there, and it consists of bicarbonate ions, which help reduce the pH of the environment down to about 6.25. So it's not too far from neutral, actually, but it's slightly acidic. The juice, the pancreatic juice, also contains various enzymes classified as proteases and peptidases, which break down proteins, and it also contains lipases and esterases that break down fats, and also amylases that further break down starches. It's a concoction of everything. Proteins that had initially resisted digestion in the stomach are now hydrolyzed by proteases such as trypsin and chymotrypsin, and are broken down into amino acids and smaller peptides that are absorbed by the enterocytes of the small intestines. Meanwhile, the carbohydrates are broken down further by amylase and glucosidase into monosaccharides, which are simple, very simple forms of sugar. Oligosaccharides, which are basically chains of small molecular weight sugars, and disaccharides, which are small but different low molecular weight sugars, are both digested by the brush borders of the small intestines, which is composed of these tiny little microvilli. And because the microvilli look like these brushy bristles, they literally just came up with a amazing name of brush border. and so why can't we have biology this simple, guys? Just call it brush border, or I don't know, painting, or
toothbrush
printer,
field. I don't know.
Chair. Kitchen. Can we call the small intestines kitchen or pantry where food is stored? I don't know, man. Interestingly, at least in animals, the concentration of these brush border enzymes can increase with the increase in the carbohydrates in the diet. Fascinating.
It sounds like a demand-driven process. That's interesting.
Yeah. If you fire more 50 cal bullets at them, they're going to build more bunkers.
Okay. That's pretty extreme, but it works.
Man, I've been reading the book about World War II. What can I do? I can't help it.
Your brain is tainted with that stuff right now, so I get it.
Pacific Front. Wait till I get into the Expanse books, and then everything's going to be sci-fi references in the podcast for like forever. Fats are digested by the pancreatic lipase, phospholipase is A2, esterase, cholesterol, and pancreatic lipase-related proteins. The digestive process of fats breaking down is called lipolysis, and they release 2 fatty acids and 1,2-monoacylglycerol. Alongside, the liver produces bile, which is a dark green-yellow fluid that consists of bile salts, phospholipids, cholesterol, bilirubin, and electrolytes. The bile salts combine with oil droplets and serve as transporters for lipolytic products to the enterocytes. Long-chain fatty acids are broken down into free fatty acids, and they can form insoluble soaps with calcium ions within the small intestines. What's interesting to note over here is that these soaps can slow down or reduce the absorption of long-chain fatty acids and may instead be secreted due to their inertness. So you just throw them out of your body through your rear side. It's fecal matter.
That's a diplomatic way of putting it.
People are learning new ways for us to express science.
And we just figured out that the body likes to create some type of soap to digest our food, which is very fascinating to me.
Man, these scientists use their own terms.
Yeah.
Like, for example, some people call butter plastics.
I've heard of that, and cheese as a plastic even, and meat as a gel matrix.
Yeah.
It's kind of strange sounding, but as you think about it, it makes total sense. And I think, especially if you've looked under a microscope, you'd totally understand that.
Yep. Cake as a sponge, whipped cream as a foam. These are food science terms. Like, food science is right now, guys, it's really fascinating. Food science is merging with nutrition science and biochemistry. There's a lot of fun stuff going on right here. Anyway, when it comes to mechanical processing, we were talking about the mechanical processing earlier, the small intestines also perform peristaltic constriction and relaxations, which push the food towards the large intestine, while at the same time mix the digesta with pancreatic juice and bile. Similar to the stomach having an open and closed valve, the sphincter that we talked about earlier, the small intestines have an ileocecal valve that is usually closed to prevent regurgitation from the large intestines, but opens up and allows the remaining digestive to pass through the colon or some large intestines. So, once all of this is said and done, we move on to Gondor, or colon, or large intestines. What's your take?
The fires are lit, my friend.
Rohan calls for aid. No, it's the other way around. Gondor calls for aid and then Rohan comes to help. They're coming up with a new Lord of the Rings series, and I'm really excited about that for Amazon.
Amazon, yeah. I might have to reinstate my membership.
Oh, man, we have so many shows that are coming up.
Indeed.
Guys, buy our energy pod so we can start watching shows.
And we can make more nerdy, fun references on our podcast that are laden with scientific terms that may put you to sleep.
Yeah, I think some people probably enjoy that and they laugh their ass off.
No, I like to listen to this stuff in my car.
It's a, you know, like I said, humor is important. It's a very integral part of culture, society, and I just think it needs to be highlighted. Indeed. We should laugh and smile.
Absolutely. Well said.
With that being said, we move on to the colon or the large intestines. So the large intestines is a region where food is fermented. You might be thinking how beer is fermented. It's not actually too far from that, actually. What's really fascinating is that the large intestines contain to an order of 10 to the power of 13 bacteria in human colon, which is more than the stars in the universe. So we literally have a colony of living organisms inside our large intestines, actually. And it's a lot. Millions and billions of stars.
Oh, Carl Sagan.
All right. And these are of 1,000 different species and a combined genome of more than 100 times of the human genome itself.
Man, what are we again? Are we a bacteria? Are we a virus? What is a human now?
If I am sort of buzzed and have alcohol in me, I'll give you a much better answer to that.
That sounds great.
Now, if I have some sort of a cannabis effect going on, then there will be a very different and artistic answer to that. So it depends on which kind of Fahad you are talking to. But it's really fascinating at the same time.
Indeed.
The environment in the small intestines, despite the bacteria, is anaerobic, meaning that it lacks free oxygen. Like these suckers, not suckers. Please don't kill me, you guys down there. I hope they don't have ears. But yes, the environment down there is oxygen free, which is really cool. Talk about alien life inside the human body that doesn't need oxygen, bro. That's trippy.
It is trippy. We usually find these types of bacteria like in the most harshest environment on the planet. And there's these types of bacteria that live very, 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 very deep in caves that are devoid of oxygen. Yet here we are locally. We have them in our stomachs. What the heck?
Yeah, what was that bacteria? I don't remember its name, but that thing can survive in outer space.
Oh, it was a microorganism.
Yeah.
Tardigrades.
Tardigrades. I was thinking TARDIS, but that's from Doctor Who.
Yeah.
God, I'm such a freaking huge nerd. Holy moly, man. I need some help. Is there like an anti-nerd therapy that I can go to?
No, once you've had it, that's it. You're infected forever.
GG.
There's no vaccine for it, sorry.
Okay, all right. Well, Food first passes from the ileocecal valve that was at the end of the small intestines into the cecum and into the starting regions of the large intestines called the ascending and transverse colon. See, now these are easier names.
Yes.
They came in a little later. It's like, we should just kind of make it a little simpler for our bio students. They already have these insane Latin words. But over here, in the ascending and transverse regions of the colon, fibers are fermented and converted into short-chain fatty acids such as acetate, propionate, and butyrate. And these are all low-carbon chains, basically. That's why we call them short-chain fatty acids. The short-chain fatty acids are taken up by the body and used up as a source of energy. Later, as the digesta continues to pass through the large intestines, the processing starts changing from fermentation to protein breakdown, including, very interestingly, including the proteins that were initially produced by our own body to aid in the digestion. For example, the mucins. While this is going on, water and electrolytes are recycled by reabsorption, which maintains water and electrolyte balance within the body. I mean, you really don't want to lose all the water, man. Mm-mm. So it's got this own recycling system, like a little desalination plant going on in there.
That's incredible.
So that's another food processing system inside the body, the water filtration system.
I think humans should look more closely at what the human body is doing and maybe build some cool machines that can perform the same functions on the planet.
And then we also have the 10 to the power 13 nanobot. Please don't kill me down there. The 10 to the power 13 nanobots that are just breaking down these different foods and fermenting the hell out of them.
Yeah, fermenting them, and then our body takes those things and assimilates it into more body and energy.
From this point onward, I'm not going to call them bacteria. I'm going to call them fermenter bots.
Fermenter bots.
Yeah.
I like it.
All right.
Let's move forward.
Create our new biology. All right. So, Corey, now that we've finished the whole digestion process and gone through a little bit of the anatomy, do you have anything to say over here?
Not much to say. This is very interesting stuff, and we're learning a lot. But I feel like it's a little bit more easy to digest than those last 3 podcasts we slapped you with. Minus the Danny Vega was very fun. But the 3 before that one, you guys know what I'm talking about.
Yeah, orexin 1 receptor, huh? All right, so now let's shift away to, now that we have a very good idea of how the digestive system works and it's a bit of a processing unit, we can now talk about the bioavailability of nutrients and how different macronutrients can interact and how they have a downstream consequence. So you're going to see step by step what happens. But first of all, what exactly is bioavailability of nutrients? The amount of nutrients, just to put it simply, inside the food isn't always the amount of nutrients that we can absorb. The amount of nutrients absorbed is called bioavailability of food and is influenced by how much a food is chewed, how many nutrients are expelled from the food during digestion, the absorption in the intestinal walls, and how much of the nutrient is accessible in the first place. You know, outside the scope of the notes over here, there's a lot of other factors. Like, for example, if you're in a diseased state or you're sick or something's going on or you've gone through some sort of a surgery within the body, those factors can also influence the bioavailability of nutrients.
Right.
But this is just a very generalized and simple way in the context of the topic we're talking.
To put a nerdy reference in there, if you were diseased, it's kind of like when you're flying your starship around in the expanse and you take a hit on starboard and you have to divert energy to the shield on starboard so you don't get struck again by a proton missile. That's kind of what the body is here doing.
That is exactly what the body is doing.
Energy to the immune system.
Yeah, you gotta go there. You gotta send that guy who's just sleeping on the deck and tell him to go back there and divert that energy. Why did he get hired for? But it is also important to note that the bioavailability is not the same as bioaccessibility. Bioavailability is bioaccessibility is simply how much you can access out of that. It's availability and accessibility are just 2 different words. This becomes more relevant in plant foods, where the raw plants have to be processed to allow nutrients to be available and accessible. This is where I take a little bit of a controversial stance over here. Like the whole idea behind raw fruit, raw vegan diet, I just find it very odd. You have to do some processing in order to extract those nutrients in the first place, or else they're just going to stay there forever. And we know that a lot of plants have to be processed, whether it's heat treatment or whether it is through mechanical processing to extract those nutrients. So I will never be on board with the raw fruit and vegetable diet in this lifetime.
No, not for me either. I mean, unless I wanted to chew it 25 times 4 times, like really just try to break it down in my mouth. And I mean, I guess I would get really beautiful jaw muscles from doing that. But the point is that we're looking at the actual food structure here. We have to shred down cellulose, which is found in plant fibers, which bind around proteins, fats, and nutrients that we're trying to get after. And our bodies are just not well equipped on the inside to take care of that stuff. And I remember looking at a study years ago with you, Fahad, where they showed the man who had a colostomy bag on the outside of his body, and they had him eat broccoli and carrots and vegetables, and they observed what was in the colostomy bag, and you can still see like portions and chunks of this stuff floating around in there. And then they had him eat meat, the meat like completely emulsified, which was really, really interesting to me. And it tells me that the body is well equipped for breaking down something like a gel rather than a rigid surface like a cellulose fiber or a cell.
Yes, and that's absolutely true. And there are so many factors. And over the period of time, we're going to explore them. There are certain compounds that can actually expedite the flow of this digesta. So do you really want that? And then, of course, I guess the raw plant diet could be for those who want to feed their 10 to the power 13 fermenter bots.
Right.
They would enjoy a lot of food, I guess. So
what's the saying?
Taking care of your pets.
Beans, the magical fruit. The more you eat, the more you toot. Yeah.
Oh, man. So that's why I will always just like to... my personal philosophy is... My personal philosophy is that eat meat, make it as tasty as possible, process the hell out of the plants, and enjoy them.
I like that approach.
Yeah. And so... processing is good.
And we're not anti-plants, by the way, here, guys, at Ketogeek. We are putting almond flour into our energy pods here. So we're not anti-plants. Don't get that idea about us. We're just talking about how we can better utilize plants to extract nutrients and energy from them.
Exactly. And just to put it this way, that we're neither carnivores or plant-based. We just think man is basically a tool-wielding animal that uses cognition to tame the environment for their survival. And because of this evolution, we've become heralds of this land, and we like to help other animals as well and other life forms to the best of our capacities. That's what I think it is. So why don't we just put down our pitchforks between the vegans and the carnivores, and let's improve them both?
I like that. Let's do it.
All right, I've put my pitchforks down. It's in the garage right now. I don't even have a pitchfork, though. Do we have a pitchfork?
We don't, but I did put my torch out recently.
We have a rake.
We do.
Rake is similar to a pitchfork, isn't it? No?
It's close.
Okay.
You can always put it on the ground and have somebody step on it and smack them right in the face. That's always fun.
There you go. All right, I'll put my rake down and we'll move on to the micronutrients and their bioavailability. So, for instance, let's talk about micronutrients from fruits and vegetables because they are better absorbed when fruits and vegetables are pureed, ground, or thermally processed, like, for example, cooking, as these processes can rupture the cell walls that limit accessibility of the nutrients. Additionally, antioxidants such as phenolic acid in fruits and veggies are absorbed when they are weakly bound to cell walls, while fat-soluble antioxidants such as carotenoids release nutrients by chewing and mechanical processing in the GI tract, along with dissolving with bile salts in the intestines. Fascinating. Carotenoids are lipophilic or water-hating. They hate water. So their absorption is improved in the presence of fats, similar to vitamin A, E, D, and phytosterols, actually. Interestingly, this is very fascinating. I'm talking about the power of processing. In raw carrots, only 10% of carotenoids are available, but when they are processed and oil is used, this ramps up to 50%. So yes, all those people who say nutrient density is amazing in raw fruits and vegetables, I swear, they need to look at all of these things where processing actually increases the bioavailability of nutrients and by proxy increases the nutrient density. So yeah, let's talk about bioavailability before we talk about nutrient density. How much can you actually extract from the food? And I would argue the problem with the most food is not a lack of nutrient density. It might be there are too many nutrients in the first place.
Right. Here's what I'm interested in. I want to look at now, this is just kind of going off the cuff, but I would really like to look into different plant-eating cultures around the world and look at their processing abilities and then look at their health and nutrition. And maybe we can draw a correlation there.
We definitely can. I would love to check out, and I think we are going to start focusing a lot on food science in our podcast. Nutrition science, guys, we've been through it 3 years, and it's a losing war.
It is.
It seems to be a little critical here. It seems to converge towards a very naturalist approach. Mm-hmm. And for me, the reason why I joined Ketogeek is because I wanted to make the world a better place. I wanted to create better foods. I wanted to innovate, not regress. So for me, I found my home in food structure and food science, and you guys who listen to the show. And you too, Corey. You're awesome. Anyway, chewing also reduces particle size of fruits and vegetables, which increases the surface area of the food available for digestive enzymes to work in. In the small intestines, fibers left from food digestion can form polymer chains and insoluble sponge-like networks that can modulate digestion and the absorption of nutrients. For example, fruit tissues consisting of fiber can trap antioxidants or impact the mixture within the stomach and intestines and consequently reduce the rate of absorption of these antioxidants. So this architecture plays a huge role. Anything you got?
Let's keep moving.
Righto, partner. All right, so carbohydrates. Carbohydrates exist as granules of 70 to 80% amylopectins and 20 to 30% amylose, both of which are basically glucose polymers. These starchy carbohydrates digest and hydrolyze at different rates depending on where they came from, what kind of processing they went through, and what their physiochemical properties are. Mainly, however, this is dictated by three factors. 1, the structure of the plant material outside of the cells. 2, surface of the starch granules, which can control the exposure of digestive juices to the starch network itself. And 3, packing and the type of networks between the amylopectin and amylose molecules. There's a lot of interlinking about these things.
Indeed.
Native starches, which are basically pure forms of starches, depending on their source, could be potato, maize, wheat, tapioca, are either digested very slowly or may not digest at all. These starches don't dissolve in cold water and are used in several commercial food products as thickening agents as they bulk up depending on the temperature. So Corey, now we're factoring in temperature as well. However, this bulking or swelling pushes out the amylose. It extracts out amylose and amylopectins, which can now dissolve in the water away from the indigestible part within the digestive tract, thereby making them available for further digestion and absorption. Kind of cool. Mm-hmm. Furthermore, an increase in amylose content inhibits starch hydrolysis and increases the presence of resistant starch, which is basically recrystallized amylose after heating and cooling the food product. So now we're seeing how resistant starch is also being formed over here. Many starchy foods also contain proteins, which can create a network around the starch granules that can impact its gel formation capabilities and modify the capacity of forming resistant starch as well. Now we're throwing proteins into the mix as well. So this architecture is forming. This presence of proteins can potentially slow down the digestion of starch by inhibiting the access of amylase, which is the enzyme that digests starches, to the food network. In many starchy food structures, the presence of soluble dietary fiber can increase the viscosity of the food and consequently slow down the gastric emptying of the stomach. The presence of fats, we were talking about proteins, let's talk about fats. The presence of fats can also impact the starch network and is dependent on the type of fat and how it is woven with the starch network. With all of these factors that we've talked about considered, the rate at which starch is hydrolyzed determines the blood glucose response and whether the absorption of glucose is more than the clearance rate within the bloodstream. This further dictates the insulin response required to clear out the glucose overload and bring the glucose levels to normal. This is probably why some low glycemic foods work when it comes to blood sugar control, response, and potential long-term consequences within health. So now you see how these tiny little factors, these interwoven factors between proteins and starches and fats, and potentially all three of them create a network which can modulate how the starch network is disintegrated within the digestive tract. And that is what dictates how much sugar is in your bloodstream, and that dictates how much insulin is going to be shoved in there. So now we're drawing an interesting conclusion. This is magic.
It's fascinating.
Indeed. So this is very relevant to people who are on a low carb and a ketogenic diet or maintaining their blood sugar. Now you can understand how the architecture of food plays the key role in dictating all of these factors. And you can now go down to the molecular level, to the forces that are repelling, whether it's something is hydrophobic or hydrophilic. You could understand at that level what is going on here. It's powerful knowledge. Now, Corey, you got anything to add before we move on to the fat?
No, I want to eat some fat right now. Let's go.
All right, let's take an energy pod break.
Oh, yes. Small pause.
Oh, man. I'm going to try the energy pods today with strawberry. I'm going to toss some chocolate chips into the energy pods. Then I'm going to chop up some strawberries, put them on top of the pod, and then I'm going to spray some whipped cream on there.
I want that.
Yes, I'm going to consume that as my late night dessert, and it's going to be amazing.
I am there with you. Let's do it.
Oh, man. Anyway, let's go to the fats. Fats or lipids are an essential macronutrient that are derived from both animal and plant sources. About 95% of the fats that we consume are triacylglycerols, which are basically three fatty acids esterified to a glycerol molecule. So just take your finger, turn it into like a 3, and then just one palm, sort of like that. 3, 1. I wish I could have shown that. We should do video podcast. Sources of these fats include meat, dairy, nuts. There's so many sources, man. Fat is king.
It's everywhere.
Yep. The remainder, besides these triacylglycerols, the remaining 5% is composed of phospholipids and cholesterol. So phospholipids are fat molecules with one hydrophilic or water-loving head and two hydrophobic tails, water-hating tails. You can try to imagine that, I guess. Water-loving. I was thinking of, oh man, where the nerdy reference comes in. I'm thinking of the Fluffy from Harry Potter.
Oh, yes.
But the Fluffy had 3 heads.
Yep.
Think about Fluffy with 2 heads, 2 tails.
Yeah, one of them wakes up and the other 2 are still sleeping.
Yeah. Actually, Fluffy with 1 head and 2 tails. That's how people need to think.
I gotcha.
That makes no sense.
No.
All right. Okay, so now what about cholesterol, though? Cholesterol is a type of yellow crystalline fat that is created by animal cells and serves as a precursor for steroid hormones, bile acid, and vitamin D. So anybody who says, hey, cholesterol is the bane of the universe, it's actually kind of important, y'all.
It's a big deal.
Yeah. In many raw or unprocessed foods, triacylglycerols are coated with layers or membranes of phospholipids and these proteins, which help in making fat soluble. Now, this is really fascinating how fat dissolves. Because normally, Corey, if you put oil into water, it doesn't dissolve, right?
No, it generally just floats right to the top.
Bingo. So there's some magic that's going to happen now. In processed foods, oil and fat is extracted and then used to create an emulsion, which consists of oil and water concoctions such as yogurt, cheese, spreads, dressings, ice cream, chocolate.
Oh, I love all those things.
And energy pods.
Yes. And guess what all those things have in common?
Energy pods?
They're all processed.
Or they're all processed.
And we love them.
And we love them.
So, yeah, processed foods are not evil, by the way.
I still want to consume that ice cream thing that you made. Man, that was good.
Oh, it was vanilla ice cream with fresh jam, by the way, audience.
Homemade
Fresh jam.
Oh, man. In these products, which we mentioned, for example, the dressings, butters, nut butters, and so forth, they commonly use di and monoacylglycerol. So if you look at the label, you might see that as an ingredient. And they also use phospholipids like sunflower lecithin, soy lecithin, and all those kind of things. And then also proteins, they might use like milk powder or whey powder or any of these things. They use all three of these to stabilize them. It's really fascinating. Just go to your shelf and start pulling out your nut butters or any of these fatty products, and you're going to see one of these in there. They're there to stabilize and improve the texture of those products. But now you know what they do.
Yeah, if you've ever had completely organic and completely natural peanut butter, you may know that it completely separates and there's no stabilizers in there. So if you like to stir and get really nice forearms, I suppose you can keep buying that stuff.
Yep. And in our energy pods, we do use lecithin and we use whey proteins as well, whey protein concentrates. So these are our stabilizers. But because the ghee is sort of like a semi-solid, it is already sort of stable. So we don't need to make it more saturated by adding di and monoacyl glycerols. And we kind of like that semi-solid texture, which is relatively unique. When it comes to digestion, first the structures around the fat are broken by our digestive system, and then fat droplets are released from that structure, whether it is from seeds, nuts, animal tissues, or even processed foods like energy pods. Physical processing in the GI tract releases the triacylglycerols, but these are generally insoluble, while the lipases, the enzymes that break down the fat, are water soluble. Oh, we have a dilemma here. So, and this is why digestion and breakdown of fat takes place at the water and fat interface. Cool. So where they meet, where the Pacific and the Atlantic meet, that's where digestion happens of fat.
That's where all the fatty tuna are swimming around.
Yeah. It's a horrible analogy, but
just imagine it. Roll with it, guys and girls. We're having fun.
Yeah, just imagine the Pacific Ocean as fat and the Atlantic Ocean as water. So that the part where they split and merge, there's a line there. Just imagine a line, and that's where the digestion of the Atlantic, or what was the fat ocean, takes place.
Yes.
Okay.
The Pacific.
All right. So consequently, anything that impacts the binding of lipase to this interface, this line, will impact its digestion and its rate. These things could be emulsifiers like the lecithin and the surface area of the interface itself. Like if it's a big line spreading from the North Pole to the South Pole, there's got to be more stuff going on, yo. And also the droplet size of the fat itself.
I kind of want to create a video game that helps people understand this. Like you have to use certain different types of enzymes to break down certain different blocks that are binding the fat in the water or the nutrients and whatever we're going after. And I think that would really help people understand. What do you think?
I think that's a fantastic idea. That will be the future because as we know, people... And sort of going on a slight tangent over here, I think that overall, we're going to move away from cooking at home. 90% of the people in our country, in the United States, don't like to cook. The 10% are lying. I'm just kidding.
And that's, that's a good observation because we have stuff that exists like fast food, McDonald's, Wendy's, Jack in the Box. So you have restaurants. These things exist because people want to have more time to enjoy their family and friends and not have to focus on cooking every single day. That's just another chore you have to add. But I do have to admit that I've always loved cooking and it's a fun thing to do, especially when you're good at it and you can weave a symphony of food and impress your friends and family and create awesome memories from that.
Exactly. And that's totally fine. Like, for example, we love listening to music on Spotify or Pandora or any of these apps. But at the same time, we do love playing the guitar. We love playing piano.
Doing it yourself.
Exactly. It's an experience. So my whole drive here, ideology here, is that cooking should be optional.
Right.
Not mandatory. Especially when it comes to, we're going to do a podcast about the joy of cooking. It's a very interesting topic where we talk about how cooking will... We think of cooking as this holy grail, but in reality, there's dark realities behind cooking at home. And a lot of these recipes are just so inaccessible for a lot of people who don't have a lot of money. and they've got children complaining that, oh, this recipe isn't right. So the dilemma of a mother who's raising kids, like those are issues that we need to talk about. So the so-called joys of cooking is going to be a very important topic. I want to talk about it. So as we mentioned that food emulsions can contain various emulsifying and binding agents such as phospholipids and proteins that can engage with this so-called interface we talked about at its surface. This can have a significant impact on the action of the lipase with the fat droplets. It is also very interesting to note that solid fats have a slower digestion rate. The solidification can be attained by hydrogenation or interesterification. Now, what exactly are these two things? Because they are used in food processing. Interesterification is simply the swapping out of fatty acids, whereas hydrogenation is adding hydrogen to unsaturated fatty acids to turn them into saturated fatty acids, which is how food industry turns vegetable oils into margarines and butters and all those kind of things. So that's basically the chemical reaction right there.
So it's pretty much a difference of structure between these two things and not some esoteric, mythical, oh, this is evil kind of a thing. We're just adding one little component and completely changing the structure.
Yep. That's basically what all of these things do. You can look at the ingredients right now and you'll see the same thing. So this is all the power of discernment and knowledge over here. But the question still remains, Corey, that how does butter compared to vegan butter? Now, we have a controversy in the keto world and low carb world. I honestly, after these 3 years, I think both of them are kind of okay-ish. I think butter gets my vote over here. Perhaps because I'm biased, but I do like butter way more. The cookies that we make, the kind of foods that we make, the aroma, the ghee is just out of the world. And vegan butters have a bit of a way to go, more like margarines.
They have some time to learn. I have to say, though, that the structures are pretty similar. They're very close. Butter does solidify and harden a little bit more. And maybe that is due to the extra components that vegan butters are missing, proteins, for example.
Yep. We'll have to break it down in order to understand more of what's going on. But you're right. Vegan butters, more like margarines. They call it vegan butters nowadays. And just to give it a good name. So, however, it's important to note that consuming fatty foods, blood triacylglycerols or TAGs levels increase within an hour and can remain high for several hours. This increase in triacylglycerols after a meal is because of the increase in the intestine-derived chylomicrons and liver-derived VLDL, or very low-density lipoproteins, which is, as we notice, is due to the type of lipid or fat digested and the overall matrix of the food. Saturated fats have a more pronounced and longer-lasting elevation of triacylglycerols in blood compared to polyunsaturated fats. Short and medium-chain fatty acids, one of the ingredients that we use is MCT oil, are rapidly absorbed by enterocytes and transported through the portal vein into the liver for beta oxidation. So they have a different pathway here. Long-chain fatty acids, on the other hand, are absorbed by the small intestine in enterocytes and transported through the lymphatic system as chylomicrons. Absorption of long-chain fatty acids also releases CCK, or cholecystokinin, which is a satiety hormone, in the small intestines, thereby inducing the feeling of satiety. But we know that the feeling of satiety doesn't always correlate with a reduction in energy intake. That's a very important thing we learned in the last few podcasts. It is also noted that fat-based emulsions that are acid stable slow down gastric emptying and increase satiety, and also post-meal cholecystokinin, or the satiety hormone, or the purported satiety hormone. The droplet size of the fat also has an influence, and it was shown that smaller droplet size was digested to a large amount due to increased surface area, but interestingly also slowed down the rate of gastric emptying. Also interestingly, a study done by Dr. McClements. Do you know who Dr. McClements is?
I remember him as a guest on our show.
He was a food scientist. Yeah. I had to mention his name because it's a study by him.
Nice.
A study by him showed that in type 2 diabetic subjects, an equal calorie diet containing milk, which is a liquid, Butter, which is a solid, and cheese, which is a semi-solid, had no impact on the duration of post-meal elevation of blood triacylglycerols.
Interesting.
Yes. However, the gastric emptying rate was higher with cheese than with milk.
That doesn't make sense.
Well, they do a little bit of an explanation actually over here. In mice, ingestion of milk fat with skim milk resulted in faster appearance of blood acyltriglycerol and sharper peak than ingestion of homogenized or non-homogenized cream. So notice over here, the appearance was faster when they used milk fat with skim milk. So there were two different components, not connected together. So it was faster when compared to like if it was just straight up milk. So different impact.
Interesting.
It can be concluded that the structure of the food and the water and oil interface can have an impact on the physiological response from fat. So this may have more to do with the interface that we were talking about, the oil-fat interface, rather than what kind of state it was in. Because we know that the digestion primarily happens, or the breakdown primarily happens, when this interface is shattered or it engages consistently. Mm-hmm. So we don't know. Additionally, it was noted that butter leads to higher fasting total LDL, low-density lipoprotein cholesterol, than cheese. Emulsifying fat, for example, on the other hand, leads to an increased absorption and rapid and sharper post-meal appearance of chylomicrons in the blood. Paradoxically, even though homogenized milk has smaller fat droplet sizes, which should increase the rate of lipolysis, the presence of milk fat globule membrane, which exists in human milk, it's basically around the fat. There's a membrane there. But it's not present in the infant formula. This can speed up the digestion of the fat.
It makes me think of when you crack an egg open and you have your yolk and it's surrounded, it surrounds what it is surrounded by, the egg whites, which is mostly... Gosh, what is the word? Lecithin and proteins. And then you have your yolk, which is the nutrients and the fats. That's fascinating.
Yep. There's some interesting dynamics that are in play over here that we're trying to tease out. For example, in almonds, the accessibility of fat is dictated by how much of the cell walls of the almonds are disrupted by mechanical processing and chewing. But remember earlier that... the particle size decreases to about 1 to 2 millimeters. So there's some standardization over here. These cell walls within these almonds can trap the fats and limit the digestion and potentially the rate of digestion as well. Chewing on its own releases only 8 to 12% of fat while yielding, like I said, 2 millimeter particles. In whole almonds, a large portion of fat is not available for digestion at the start, and this was noted in fecal samples after chewing and digestion in humans, with a substantial chunk of fat remaining unabsorbed and intact within the cell walls. This is why the calories in nuts are also lower. Like they say, oh, it's like 5 billion calories in nuts. No, dude, it's not that high. They're actually quite lower, and it all depends on the kind of processing.
They should put a preface that says potential 500 calories.
Oh, and you know what's interesting is that even when you do process nuts, there's something called dietary compensation. And people don't... I love how the fitness community doesn't talk about dietary compensation. They love talking about, the calories, mate. But they never talk about dietary compensation. That's such a strong compensator. Okay. Dietary compensation, what it means is that if you eat a certain amount of food, and if it is fully compensated by a reduction in energy intake, then that's a good thing. But what people think here is that, because something is high in calories, I should be totally afraid of it. No, what you should be afraid of is something that has a very low compensatory response. In other words, that if you eat, for example, you could eat 2 calories, but if you eat 2 calories every 2 nanoseconds, exaggerated example, then you're going to pile those things up because you're not feeling full and it's never going to get compensated. But if you eat, let's say, 1,000 calories in one meal, but it is fully compensated and you don't feel hungry, you are having a good day and you're getting your results in your diet, which, 1,000 is kind of still low, then what's the problem? There is no problem.
There isn't.
So dietary compensation, I think we should do a podcast on that just to clear out those things. But people are afraid of calories. We live in a culture where we're afraid of food. That needs to change. Food is tasty. It's good.
I agree.
So anything you want to add here, bro?
No, I just have to say one remark. And if you're fearing food, you're going to create stress in your body as you go to the grocery store, and you're going to fear everything. And I remember being in that place back when I sourced only organic foods and sourced only non-GMO foods. And going to the grocery store was kind of a stressful situation, and I didn't really like that. And I think that's because I was not sharpening my tool of discernment.
Bingo, and you've nailed it. When we get into the podcast of the so-called joy of cooking, I don't know if that's going to be the exact title. We will talk about that we push so many health recipes upon people, and we make their lives miserable. And those recipes, a lot of the so-called healthy recipes, are absolutely revolting. I've tested some of the keto products, and we even started off on the same boat. Our product has evolved now. We were told that disgusting is supposed to be tasty and healthy. Well, not tasty, but healthy.
Right.
And now you and I are literally on what someone would say hyper-palatable, insane, addictive diet. We are eating like we're in heaven.
Pretty much every day. Someone asked me, do you actually eat like that every day? I'm like, yeah, like a king.
Yes. Desserts, tasty food, steak.
Yep.
And what, no vegetables? Nah.
And I have to say that we are sort of outliers in the situation. I understand that people have allergic reactions. I have zero of those, so I really cannot empathize with those folks who have that stuff. I suppose my mother, she does have some allergic reactions to foods, and she cannot eat those things anymore. But we have to consider ourselves pretty dang lucky that we can have free fare and range.
Yes, and that's a very important point. Just because we're using our anecdotes doesn't mean that it will 100% apply to you.
Exactly.
But what we do is that if we notice as some sort of an anecdotal, we try to tease out the mechanisms and start to see if there's any sort of scientific evidence to it. So... But the problem we see in a lot of in nutrition science is that, especially in the keto and low carb communities, and probably in the vegan, like I listened to that. Remember that banana girl thing on YouTube? She posts this one associative study to back up our claim. And you and I were just like jaw dropped at how she's getting 80, 90, 100,000 views for videos. What is wrong with humanity? That was just a slump for me.
Yeah. Underwhelming.
Yeah. So, but man, you got to test out. You got to look out for information. And the last thing we want is the public that is afraid of what they eat. That is not a society you want to be in.
That's a fear-based society right there.
Yeah. And I hold very controversial opinions about this topic because sometimes in the health and nutrition community, it's less about science and more about projecting your own demons onto other people through fear. And you should be very cautious about those kind of narratives, those kind of lifestyles. The biggest reason why any diet fails is because of lack of sustainability. All these nutrition all these people that talk about these clinical trials and clinical studies, the failure rates are absurdly high. And a lot of these interventions work because there's ongoing interactions with the clinicians. Outside, free living, you're on your own. But we over here are teasing out these mechanisms so you guys can prepare yourself and make better decisions. We have one last piece to add over here. I know we've talked about carbohydrates and fats, but we have this tiny tidbit on proteins left. And proteins basically form building blocks of the body and can be derived from both plants and animal sources. Animals usually have a complete source of amino acid profile, but plants can be fortified and made to work as well. You have to do a little bit of a processing.
Oh, I like that.
Yeah.
Processing.
Plants... you have to process plants. The vegan diet has to be processed.
Absolutely. I mean, go ahead and try to eat soy all on its own. No, you're not going to do that. It's not very tasty. You're going to eat tofu. You're going to eat probably edamame, which is also a processed soybean. Try to eat that stuff. I wouldn't even try to eat it raw, to be honest with you.
We need to create a sequestering diet that converts... Expanse reference again. Sequestering diet that converts minerals and atmospheric gases into nutrients.
Now that is the future.
Guys, buy energy pods. We're working on a sequestering diet.
Do it.
That's my dream come true. Just turn Mars into a place where we can live. And it makes sense because we literally are on a collision course with Andromeda Galaxy, and our sun's burning out, bro.
Yeah. I mean, on a galactic level, it's pretty soon.
I know we love to watch those Instagram and TikTok videos, but we are a bit on a time limitation.
That's right. We can kind of mess around a little bit, maybe for 1 or 2 more, not even a cosmic second. We've only existed for a cosmic second. We have a cosmic nanosecond to laugh at these videos, but we need to get serious.
Indeed we do. Like we're about to get serious about proteins. So proteins are used to make gels, foams, supplements, and intensively as industrial and culinary ingredients. It's fascinating. Protein is magical. Many processes can impact protein structure, such as heating can lead to the denaturing of protein. For example, raw protein versus scrambled eggs. And basically, heat treatment leads it to this folded microgel structure in protein in the form of a cooked egg, or in combination with other compounds to produce a unique or desirable result. For example, the Maillard reaction, where there is a rigid browning effect on bread and meats when proteins react with sugars. And it also modifies the structure as well. It hardens up, toughens up.
You get that nice crispy steak exterior. Think of it like that.
Yep.
Everybody likes that crunch.
And downstream, that has an impact on how the proteases are going to act on your steak. The Maillarded steak.
Thank you, Maillard.
Interestingly, these structures can influence the effect of digestive enzymes from the GI tract upon the protein structure. This can therefore impact the accessibility of protein itself during the digestion. Protein structures can be hydrophobic or hydrophilic. Casein, for example, rapidly hydrolyzes, but when there is a complex and folded protein, this resists digestion. Interesting. Protein digestion is influenced by the presence of other macronutrients and structural components. Alongside fiber, for example, there is an increase in the viscosity of the digesta and or limited access to the cleavage sites where the enzymes, the protein digesting enzymes, can act upon the protein for further digestion. Phytochemicals such as folate and phenols, primarily found in the plants, can bind to the proteins and reduce the bioavailability of the digestible proteins. Some proteins are digested slower and some are digested faster. When casein, we were talking about how it hydrolyzes faster. However, when casein, despite all of this, can also aggregate and meaning collect together and lump up and delay gastric emptying, which can reflect a delayed amino acid peak in the bloodstream. Now, this is me just speculating. Perhaps this could be a combination of both whey and casein together, where casein slows down the gastric emptying, while whey, despite being a little faster down the road, releases satiety hormones, potentially signaling fullness. So it may be not just whey or casein, it may be whey and casein and so forth. But this is just speculation. But this basically ends up our sort of introduction into the human digestive system and food structure, along with bioavailability of carbohydrates, fats, and proteins, and some micronutrients involved. Corey, I leave you the stage. What do you think, mate?
I think this has all been a wonderful podcast. It's really highlighted what Ketogeek has been on a journey for the past couple of years, maybe even 3 years. And it's hopefully has given you guys a shed of light on what is actually happening in the body when we consume different types of food with different types of structures. And perhaps it loosens your grip of fear on what processed foods are. And we learned that you can weave a beautiful network of food and consume it, and we can make it do what you want it to do in the body, because we understand now maybe only 25% more of what the body is actually doing with this food. There's much to learn, and Fahad and I have discussed in the past that we want to perhaps build a vitro model of the entire digestive tract. I think that would be very fascinating to watch it with our own eyes.
I would be really happy to build that Vitra model in-house at Ketogeek and do some experiments with our energy pods and compare it with other food products so we can usher in a generation of better processed foods. Guys, this is very important over here. A very, very important calling, I would say, over here. That I understand, and I've mentioned it before, the energy pods are slightly pricier. You can think of them, each pod, as an expensive craft chocolate, because that's how much effort that goes into them when it comes to starting from scratch, finding the ingredients and putting them all together. But what it does do is that we use our profit margins and we throw them back into Ketogeek. We don't make a lot of money here. What we want to do is take this money, put it into our own research, and create these models, create these different things that we're dreaming about. And these will help you guys down the road. Anything good that happens in the world, it spreads out. Now, people may think, for example, that Tesla is a controversial vehicle. Some are for electric, some are against electric. That's agnostic. I mean, let's take an agnostic point of view over here. What it did do, as we can use that as an example, is that despite the pricey car, people invested in a dream, and it eventually ended up spreading to other car manufacturers, to other people, and collectively we created a huge change in the world. Now, the vision can be disagreed with, but it did happen. This is what we are aiming for as well. And with the energy pods, that's my goal. That's our goal. We will change the world. That's our vision. That's our promise to you guys.
It's a good promise to have, and I think it's a very, very good vision moving forward for humanity, the future of foods, and hopefully just demystifying things that we don't really know about, and to remove fear from people's minds and create more of a fun and stress-free world to live in.
All right, well, Corey, I think this is all we got for today, and thanks to everybody who listened to the podcast. Go check it out. Go leave us a review on wherever you can find us. Go buy energy pods and leave us a review for that too. It really supports us. Thank you. Thank you for listening to the show. You can visit us at ketogeek.com to check out our premium keto-friendly and low-carb food products, including our infamous energy pods, made from the best ingredients we could find in the entire country. We also recommend signing up for our newsletter at ketogeek.com/signup, where you get exclusive discounts, rewards, product announcements, and the latest content we are working on. You also get a 10% discount on your entire order when you sign up. Go to ketogeek.com/signup to join the low-carb playground.